Hey everyone, let's look at the second example from video 8C. This example gives us the position of a particle and it gives us an equation, x equals negative 4t squared minus 2. So that is the position as a function of time. The first part of the question says, what is the instantaneous velocity at 2.5 seconds? Do you remember what equation to use to find this or how to do this? Well, instantaneous velocity is defined as the derivative of x with respect to t. So all we have to do is take the derivative of this function with respect to t. So that's going to be negative 8t for the first term here, and then 0 for the second term when we differentiate with respect to t. So the velocity as a function of time, and we can put v in parentheses t to show as the velocity as a function of time. And now we want to know, well, what is the velocity at this particular time? So all we have to do is plug in that time into the equation. So the velocity at 2.5 seconds is going to be negative 8 times 2.5. And that's going to be negative 20 meters per second. Let's look at the second part. What is the average velocity between 3 seconds and 4 seconds? So think about the definition of average velocity. The definition of average velocity is delta x over delta time. We know the change in time is 4 minus 3 seconds, or 1 second. We need to find the change in position or the displacement. So we need to find x final minus x initial. Let me just rewrite this actually as t final minus t initial in the denominator. So to find x final, that means x at 4 seconds, we just need to plug in the 4 into the equation for position. So we're not using the equation for velocity in this problem. We can do this on the side. X at 4 seconds is equal to negative 4 times 4 squared minus 2. That's going to give us negative 66 meters. And then we're going to find x at 3 seconds by plugging in a 3 for the time. So minus 4 times 3 squared minus 2. That's going to give us negative 38 meters. So now we have our final and initial positions, minus 66 minus a negative 38, that's in meters, over 4 minus 3, and that's going to give us negative 28 over 1, or negative 28 meters per second. So we do have a negative average velocity and a negative instantaneous velocity at that time. And that makes sense because if you plot this curve, the curve will look like this. If you plot it, it's going to look like a parabolic function. And so when you are in a positive for time over here, then you can see that the slope is negative, which means a negative velocity.